Right. So in the previous class, what we saw is an introduction to network. Network is not just to communicate. Network is to share resource, and network is to do e-commerce. Network is to do remote conference, education, online, many things, banking. And we also saw there are various components involved in providing the network connectivity. In that we saw beginning with amplifier followed by repeater. The difference between these two is amplifier amplifies anything that comes inside. If noise comes with the data, even the noise gets amplified. As a solution, a repeater was introduced. That filters the noise and only regenerates the data. But the repeater is not a big device. It cannot handle more traffic. There is only 2 ports. There came another device called hub. Hub is a multi-port repeater. After hub came bridge. The difference is the amplifier, repeater and hub, they are layer 1 device. They never learn MAC address. They don't learn MAC address. They don't learn MAC address. As a result, they do not know who is connected. So every time when a packet arrives to a hub port, that packet will be broadcasted to all other ports. To understand this better, I want to remind you something that you might have learned in your college days, a bus topology. Now, any packet that hits this port will be sent to everyone. That is what called as flooding or broadcast. Why it is sent like that? Because this backbone don't know where is who. Who is connected where. This is physical bus. Inside the hub you have a logical bus. Inside the hub, this is the exact setting logically inside. Whereas on bridges, they have a capacity to listen to the incoming frames, incoming packets, and learn the MAC address. For example, if this PC's MAC address is AAA, BBB, and if this port is 1, port number 2, port number 3, and port number 4, as the traffic comes in, it starts learning and maintaining the MAC table. So it learns that on port number 1, AAA is connected. And when packet comes from B, it learns that on port number 2, BBB is connected. After a period of time, if you see, it would have learned all the connected device location. As a result, if this A talks to C, if A talks to C, the packet will be like this. The MAC address is source AAA, the destination is CCC, When this packet hits this port number 1, first the bridge will check whether this MAC address is already learnt. Yes, it is learnt. If not, it will learn. And where the packet wants to go? CCC. Do I know the information about CCC? Do I know where it is connected? Do I know? Yeah, I know. It is there on port number 3. So what it does, it takes a unique path to deliver the packet. This avoids collision. That's why we say every port has got a collision domain. Every port has got a collision domain. Collision controller. It takes a unique path once it knows the destination. See, if this packet is sent on this wire, it will be broadcasted. That is that one broadcast domain, no? Bridge has got one broadcast domain, we learned. If the destination is unknown, it will be placed in this backbone so that it can go to everyone. But when the destination is known in the MAC table, there is no need to put it in that backbone. It can take a unique path to reach that port. This avoids collision. If everyone is using this common backbone like a hub, then bridge cannot support more ports. Bridges learn MAC address. That's why we call bridges a layer 2 device. MAC address comes in layer 2 of OSI. Switch is also same. Bridge and switch, they both comes under layer 2 device. They both learn MAC address. They both are called as intelligent device. The difference we saw, bridges can't handle more traffic because they got just one processor to manage the switch functionality, layer 2 functionality, whereas bridges got one processor as well as many number of ASIC chip, ASIC, application specific integrated circuits. As a result, switches can have more ports. More the ASIC chip, more number of ports they support, more amount of traffic they can handle. We have 24 port switch, 48 port switch, 96 port switch, and also big switches like 300. Let me show you some pictures. Yeah, so they come in various size. 96 port, 300 port. Whereas the bridge is limited. It's a software based device. They don't have many ASIC. But both learn MAC address. We do have bridges. Bridges are used in small office or even in home, we have bridges. Like connecting CCTV cameras or some computers like less than 12, 15 computers. We buy bridge, but in the market they call that also as a switch only. They don't call it as bridge. All right, these are all the things that we saw in the previous class. Do you have any question on what we learned yesterday? All right. Then we will get into next device called router. See, to draw a router, you need to just put one circle, that's it. If needed, you can also do like this. This is how we draw a router. A switch, we just draw a rectangle box like this. Optionally, you can put the lines like this. Switches, we draw like this. Layer 2 device. Layer 3 device, we draw like this. Router. Now the big difference is the layer. Switches do not understand. Switches, they don't understand IP header. See, we are going to learn OSI layer. In OSI layer, in layer 3 IP address comes. The protocol IP comes. That protocol IP don't work in this box. Only Ethernet works in this box. Only the layer 2 protocol Ethernet works in this box. LAN protocol. So they don't read the IP address. They don't take decision based on IP address. Switches take decision based on MAC address. They can only read layer 2 information in a packet. Okay, see, if you buy some product, international products, they will give you a catalog with multiple language. That manual, no? For example, you are buying one laptop. I don't know about laptop, whether they give. If you buy a television, not in the local Indian market, I'm talking about international market. When you buy, for example, if you buy a TV in Dubai, definitely you will get a manual with multiple language. You will have English, you will have same content in French, you will have same content in German and Spanish, Arabic, Hindi. In various language, they print and they put it inside the television box. Why? Because nothing is manufactured in Dubai. Everything is imported, and they sell it there with no tax. So it is cheaper. In Dubai, if you buy a television, you will see made in Egypt, made in China. Same TV, Samsung, let's say, or Sony. Sony TV, they will say, sir, this is little costly because it is from Egypt. Same Sony TV, they will say, this is from that country, so it is cheaper. Same size, same TV. Made in is different. Made in which country is different. The shipping cost, all the stuff matters. So, the manual, no? Because the customers are from various parts of the world, they provide a manual with multiple language. Now, when you read that manual, your eyes go straight to what? The English content. You don't know Arabic. I don't know French, or I don't know Spanish. I don't know any other language other than English in that manual. So my eyes don't read other stuff. Only the English paragraph I read. Likewise, when a packet arrives to a port on a switch, when a packet arrives with many layers of information, switch only reads this layer 2. And in layer 2, what do you have? Source MAC address, destination MAC address. Based on that, the switch will say, okay, packet is entering here, it should leave on this port. There are many ports, but it says the destination is connected here, so packet will leave here. Only based on the MAC address. Switches can't read the IP address, which is layer 3. Switches can't read, it can't read. But it is there in the packet. The packet that enters inside the switch, it has got all 7 layers. Switches can't read other layers. Now this router can read this as well as this. And now it can take decision based on layer 3. Routers take decision based on layer 3. They don't take decision based on layer 2. They don't do that. Traffic for same network, they don't do. Routers is to connect multiple networks. I repeat. Layer 2 devices help you to communicate between the devices that are in same network. Switches helps to communicate between the devices that are in same network, whereas routers helps to communicate between the devices that are in different network. Let's say this is 10.0.0.1 and this is 20.0.0.1. This is 30.0.0.1. These three are not in same network. This is 10, this is 20, this is 30. They're not in same network. So you need a router to communicate because this is network, different network. IP is different. Whereas the switch, this computer, IP is 10.0.0.1, 10.0.0.2, 10.0.0.3, 10.0.0.4. The IP is same. The network is same, not IP is same. Network is same. Only the last host portion is different, but all belong to 10 network. All belong to 10 network. If all belong to the same town, if all your friends are in same Usalambatti, I don't think you will go to a post office to post an greeting card. You can directly go and deliver it. You don't need a post office. Post office you will use only if your friend is in a different town. Your friend is in different town, you want to send a greetings in 90s. In 1980s and 1990s we used to do this. We used to put posts in the post office if we are sending to someone in the next town or faraway place. To a friend in the same town who studies with me in the same school, why will I go to a post office? Evening when I am playing only I can give him happy birthday. I don't need a router if I'm in same town. Who is the router? Post office. You don't need a post office if you are in a same town. But when you are in a different town, you and your friends are in different town, you need post office. So they only take traffic from letters from one town and put it in the wagon, put it in the van and send it to the next town. From there one cycle postman take it in cycle and deliver it. Yeah. So Router is to connect device or help communicate device that are in different network. Inside your home, you may be having many computers and cell phones. They're all in same network. So no routing happens if you are communicating from your laptop to your family member's laptop. It will go through switch. It goes through layer 2 only by reading MAC address. But if you are communicating from your laptop to Google, definitely Google is in different network, so it goes through the router to outside. If I want to talk between my two laptops, I have my old laptop to my right side table, and the new laptop which I am teaching. If I want to communicate between these two, why there is need for a router when these two are in same network? It's only local switched, not routed. So routed means what? Moving the traffic from one network to another network. Switching means moving the traffic between the devices that are in same network. A router is needed only if you are having devices in different network. In office, we use router. Even though we are all in same office, because we are in different department, each department will be given a network. Each department will have different network. So, you need router. If in case all the employees are in same network, to communicate between all the employees, you no need a router. Fine. Router is a layer 3 device. Router helps to route the traffic from one network to another. More about router is keep on coming in our training. This training is full of routing only. Now, before we move to another topic, I wish to introduce firewall. Instead of continuing this, instead of taking this topic at 9:30 today in another class, let me finish it now itself. See, firewall is also a component, very important component in our networks. A firewall is like we having a gate with lock and with CCTV camera and with the security in uniform, so that when someone is trying to enter into your house, we can verify, check, authenticate, then allow them inside the house. Without a firewall, a network is like a house with no locks. You may have a door but no locks. Anyone can push the door and come in. In some good countries we have such houses. Definitely not in India. In well developed countries, not infrastructure wise, mentally developed people, வாழ்கிறது கொஞ்ச நாள் தான். அதில் என்னத்துக்கு இன்னொருத்தந்த திருடி வாழணும், ஏமாற்றி வாழணும், நேர்மையாக நமக்கு கிடைக்கிறத சாப்பிட்டு வாழ்ந்துட்டு போவோமே, அந்த மாதிரி grown up people. That development. There are countries like that I have seen. Small, small villages they live, but they don't speak English, they don't speak Hindi, they don't speak Tamil, they speak different language. I've seen their house, full glass. You can easily see what is there inside the house. Such a transparent house I have never seen anywhere. Transparent house. And early morning, people will come and load the fridge. Outsiders, they will come inside the house and put milk inside your fridge. No one is monitoring. No one is saying, come in. They just come in and they put the groceries inside the fridge and they go. Such a trusted. But internet is not that trusted, okay? You need watchman. You need CCTV camera. You need lock and key. That is firewall. Without firewall, we will not know who enters, who leaves, what is done by whom it is done, at what time it is done. There won't be any accountability. If you have a firewall, if you have a watchman, he will have a record book. So and so came at 8 o'clock, left at 8:05. So and so came at 8:03, left at 8:10. Reason for coming, whom to visit, everything will be there. That is firewall. Maintaining logs, system logs, maintaining who enters and who leaves, purpose of visit, all the stuff. And firewall can also do this. Whatever the services that we have not allowed, it won't allow inside. Say for example, in cities what they do, they say do not allow any visitors without me approving. So if I go to my friend's house, I'm not allowed. The security won't allow me unless I show a pass. Yeah, I have to show a pass. Only then he will allow me. The security guy in the gate. They don't allow me inside unless I show the pass. So my friend should generate a pass, send it to my cell phone, and while I go there, I have to show the pass to say I am allowed to visit this place. I am invited to visit this place at so and so time. Only then the security allows me. That's the job of firewall. Employees can use the Facebook from 5 o'clock evening. That's a pass that allows Facebook. If that Facebook traffic comes at 10 o'clock in the morning, the firewall says, no, this pass is not valid. You don't have a pass to enter. Same Facebook, when it tries to enter your organization at 5 evening, firewall is allowing it because there is a pass permitting firewall at 5. You see? So it not only does this, it also identifies intruders. லுங்கி எல்லாம் கட்டிக்கிட்டு மீசி எல்லாம் முறுக்கிக்கிட்டு கபாலின்னு சொல்லிட்டு வந்தால் விட்டுருவோம்மா, விட மாட்டோம்ல. அதே கபாலி மீசியை கட் பண்ணிட்டு நல்ல பேண்ட்டு போட்டு கோட்டை போட்டு டையை போட்டு பட்டை எல்லாத்தையும் தொடச்சிட்டு வந்தா, வாங்க சார், அப்பியரன்ஸ். intruders are identified with some signature. மீசையை முறுக்கி, that is a signature. Dangerous ஆள், அவனை உள்ள விடாத. மீசை இல்லாம, you can allow him inside. That is what signature. For every traffic there is a signature. Bad traffic has got a signature. Good traffic has got another signature. So if a signature matches with bad traffic, firewall is going to say, no, I'm not going to allow you inside. Yeah. So firewalls do a lot of jobs like this. Security. See, the name is given firewall. So you put a wall, a virtual wall, and if that wall finds a fire approaching to your network, who is a fire? A virus, a Trojan virus, spam, So the websites that are categorized as dangerous, when these things try to enter into your network like a fire to consume your network, the wall is blocking them, not allowing them to consume your network, not allowing those bad traffic entering into your network that will spoil, consume your network. That's why the name is given firewall. See, this firewall comes with only layer 2, comes with both layer 2 and layer 3 capability. I repeat, it is doing firewall job. It will also learn MAC address like a switch and do switching. Or it will also work like a router, learning IP address and routing between networks along with the firewall job. So what I'm trying to say is, when you buy a firewall, this is how we draw a firewall. When you buy a firewall, you see, you put a round there. That indicates a routing. And this is the symbol of firewall. It stops the bad intruders. So if you have a big internet and you have your own network, your network people are in 10.0.0 network, but the internet is having many other networks. To help communicate between A to Yahoo, B to Facebook is what? Routing. So these also need to do routing. Yes, firewalls can inspect the traffic as well as route the traffic. So you no need to have two devices here. You no need to buy a router and a separate firewall. Firewall itself can do both for you. That's layer 3 firewall. But some vendors have got only layer 2 firewall. In Cisco we have Adaptive Security Appliance. That's the name of a firewall. This firewall, Adaptive Security Appliance, can be a layer 2 firewall as well as layer 3 firewall. By default it is layer 3. Alright, anyway, this is not a security training class. This is enough for firewall. As we do NATing and ACL in routers, you can also do NAT, ACL, access control list, network address translation, even in firewall. Okay, Now, it's time to move to next topic. Do you have any question? Okay, that's great. Our next topic is OSI, Open System Interconnect. You see, all the systems, it can be laptop, it can be cell phone, it can be a card reader, it can be an ATM machine, it can be anything that can communicate, it can be a part of network. You know, all the systems are open to interconnect. We need this model to, we need this, yeah. So, if you want all the device to interact without any hindrance, தடையில்லா சேவை பெறுவதற்கு, all the device need to be developed, built by referring to a model, and that model is what? OSI. See, this is the reference book, reference model that one should follow when they build their device. If a Dell company is building a computer for you, they have to follow this standard, this OSI rules and regulations. Because Dell has followed it, HP has followed it, they both can talk each other. See, they are all not manufactured in same workshop. One is manufactured in China, another one is manufactured in Egypt. But they both talk each other. How? Because they both followed same procedure, standard, while developing. Even the operating system, you see, you may be using Mac operating system. I'm using Windows. But whatever my mic is picking up from my voice, and whatever it is picking up from my screen, it is showing you there in your laptop. How is that possible? Whatever my laptop says, your laptop can understand and interpret it for you. How is that possible? Because both are developed by referring one common book called OSI, Open System Interconnect. Open, see, the name itself very clearly explains what is this about. Systems are open to interact, no hindrance. They are ready to communicate. My hardware profile may be different, your hardware profile may be different. I'm having a RAM of 32 GB, you may be having 64 GB. I may be having i7, you may be having AMD processor. I am having Intel motherboard, you have some other motherboard. But still they are all communicating. It is because the construction is as per the same standard. Same standard. Whenever we go to a 3-star or 4-star or 5-star hotel, we'll see same standard. when I go to a hotel, I go with an expectation. Okay, toothbrush will be there, soap will be there, shampoo will be there, towel will be there, and a slipper to wear inside the room will be there. I don't need to carry all this because it's a 5-star hotel. Right from 3-star hotel, this need to be there. So if they say it's a 3-star hotel, these things should be there. I don't need to carry. And I don't need to ask also, do you have soap, shampoo? No, I don't need to ask. Because they say we are 3-star certified. Oh, then you should have these things. Whether it is in India or in Africa. If they say 3-star standard, 5-star standard, then they should have those things. Then they will have. Swimming pool should be there. And food of various continents should be there if it is 5-star. You don't need to ask. It will be there. Likewise. Whether it is Dell laptop or HP laptop or Mac, doesn't matter. This OSI will be there. Because of that, all these can understand each other and communicate each other. Not only computers, even printers that participates in the network should be designed using OSI. Even your mobile phone. Anything that interacts with the network. Self-driving car. Definitely they will have OSI in it. Open system interconnect. So we have now understood why we need OSI. It's a common standard. By this standard, when someone develops their product, that product can become a part of internet. If not possible to interact with us. It's not possible. For example, in Kannada, Madu means do. In Tamil, Madu means cow. We don't understand, right? A Madu. Tamil guy will kick. Karnataka guy will do the word proper. If you say Madu. Madri. That re also, if it is Tamil girl, she will slap. In Kannada, re means kunju saying go, that is re. See, when the standard is different, meaning differs. But laptop standards are same, you see. International level, HP, Dell, Lenovo, Sony, Apple. There is no confusion. They all can understand the same meaning, not different meaning. Open system interconnect is a standard. Now, who proposed this model OSI? ISO. It is ISO. You know ISO certification, right? ISO certified hospital, ISO certified clinic, ISO certified soap, ISO certified pen. ISO certifies various things. This is also one of that. Any questions so far? Okay. Now we understood why is this OSI needed. Now what is this OSI? This OSI composed of 7 logical procedure for communication. We call that as 7 layers. Yeah, we have 7 layers. Is nothing but 7 steps, 7 way, 7 steps in preparing a data for communication. For example, if I need to write a letter in olden days, I'll buy one envelope. I buy one envelope, maybe 25 paisa or something, and then I take one white sheet, heading of the letter, date, from, to, salutation, body, signature, and then nicely fold it so that it can be easily fit into this, and then I paste the envelope. Now after pasting here, I write from address. In the front side I write to address, and I put the stamp on the right place where, okay, it's an envelope, they have the stamp already printed in it. It's a costly envelope, let's say 5 rupees. So you don't need to buy a stamp, it is already there. So you need to put the to address exactly where it is mentioned, from address where it is mentioned. You have to paste it, you cannot send without pasting, have to paste it. And also it should not be too bulky. They will weigh, actually they will put weight, and if the weight is above the normal, then they will ask you to add additional stamp. And then you can put it inside the box, and post office will take care from there. What I'm trying to say is, there is a procedure. You cannot simply create your own envelope. I also have paper, man, brown paper. Let me make my own envelope. Post office is giving only small envelope. I'll make big envelope. And then I'll take on big paper like a poster, write letter, and I'll post it. Not possible. Postal department won't accept your envelope. They have a prescribed size. It should be within that size. Otherwise it won't even go inside the box, post office box. What I'm trying to say is, for a envelope to be an eligible envelope for carrying it to different part of the country, if there is a prescribed size procedure to follow, you should buy an envelope, you should put from address to address in the right place, put this letter inside, nicely folded, paste it. When there is a sequence of operations that you need to carry out in order to give an acceptable envelope to the post office, there is also a sequence of job preparation that need to be done to your data, so the data will be carried by the internet. The data will be understood by the receiving devices. In between my laptop and your laptop right now, hundreds of devices are there. If all the hundreds of devices understood that meaning of what my laptop has said, only then you will get the exact voice and video that I am delivering. All those hundreds of devices understood that exact thing what my laptop is saying. No other meaning. Madu means cow, not work. Re means re, slapta, not a respectful re, like Kannada and Tamil. One meaning only. All the devices. You see? So, that preparation method, the procedure in preparing the data to be an eligible, understandable, the 7 levels of preparations are needed. They call it as layers, 7 layers, logical layers. It starts from layer 7, goes to layer 1. You cannot say the top one as layer 1 because it's a standard. இஷ்டத்துக்கு மாற்றி அமைச்சிக்கலாம்னா அது ஸ்டாண்டர்ட்னு சொல்ல முடியாது யாரும். Now this top layer is what called as application layer. The next one is presentation layer. Session layer. Transport layer. Network layer. Data link layer. And then physical layer. 7 layers of OSI. Yep. So this we need to know in sequence, not in a shuffled manner. This is the order. This is the sequence. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Okay. Your wish, you can also by heart it in this order: physical layer, data link layer, network layer, transport layer, session layer, presentation, application. Or you can also go in application down to physical. Your wish, but you need to know in either ascending or descending order in a sequence. Always layer 4 is transport, whether you come from top or down. But layer 3 is only network. Session layer cannot be layer 3. It's layer 5. That is very important. Data link is always layer 2. It cannot be layer 6. Presentation is layer 6. Right? Try to memorize this in sequence if you are not aware of the sequence. And the remaining thing about OSI we'll discuss in our next class. And do you have any question on this, what we covered today? All right. So